lung cancer would be very prevalent, but it would look genetic.
Right, right,
Right? It would because it's all because everybody's smoking, then it's not about smoking whether you get lung cancer, it's about susceptibility.
right.
So Tylenol has essentially become that way. It's so everywhere that and plus with acetaminophen, there's an extra issue that if you're lacking in sulfation, you're lacking in glucuronidation, and then there's another pathway where you can detoxify stuff. And if you can't do that, that means you're probably sicker than most people.
Hmm, hmm.
So if you're sick, you tend to take more or receive more acetaminophen. So it's sort of a vicious
Right.
sort of back and forth loop, right? You get sick, you can't process it well, but you get sick, so you get more of it
Yep.
because that's
So,
what
yeah,
people, and it's not the parents' fault, it's not the doctor's fault
right,
because they haven't been told this.
right. So we've got multiple things at play here. So if you were to take acetaminophen, if you're still developing or fully developed, that's going to be processed by your body differently. On the metabolism side, you've got a couple different pathways that can metabolize acetaminophen without producing a toxic byproduct like sulfation, like that other pathway you talked about. There's then another way to metabolize acetaminophen that will produce a toxin, and we'll talk more about that. People can vary in sort of like the strength of each of those pathways, and therefore how much toxicity will be produced at a given stage of development if acetaminophen is taken. And then we've got this other piece that we'll probably come to, which is detox. Even if you produce the toxic byproduct, we all then vary in our ability to detox ourselves from those toxins.
That is correct, yes.
Got it. So let's talk about the metabolic pathway of acetaminophen that results in toxicity. Dig into that a little bit more and tell us, where is this happening? What is the cytochrome system, and what is the actual toxin that's produced, and what does it do?
Yeah, it's predominantly a cytochrome called 2E1, right? Cytochrome P450 2E1 predominantly, but there's other cytochromes that can do it. And what it does is it oxidizes the acetaminophen, removes hydrogen to produce a quinonamine. It's called NAPQI. You'll see it in the literature because it's N-acetyl paraquinonamine. So that's the one that basically, if your body has a way to neutralize that with a molecule called glutathione,
Mm-hmm.
but if you're sick, you might be depleted in glutathione.
Right,
So,
right.
or if you can't, I mean, in laboratory rats, glutathione depletion happens really quickly, so that just with skipping 2 meals for a laboratory rat will cause them
Right.
double the toxicity of
Yep.
acetaminophen.
So yeah, let's make sure people get this piece because it's important. So glutathione is a very powerful natural antioxidant, right? So when people they talk about vitamins and minerals and antioxidants, right? Antioxidants are supposed to be good for you because they're going to neutralize things that cause oxidative stress. Glutathione is a natural antioxidant, but you've only got so much at a given time. And so if you deplete your reservoir of glutathione, then you're going to be more prone to oxidative stress. So if you take something like acetaminophen and it turns into something like NAPQI, which can cause oxidative stress, most people will have glutathione at some level that can take care of that. But if you've run out because you're malnourished or you've got some kind of genetic abnormality that gives you lower glutathione reserves, then you'll be more sensitive to damage from that molecule.
Yeah, and probably one of the biggest things that gives people problems is an autoantibody that binds to the folate receptor. So,
Hmm.
and a guy named Richard Fry at Arkansas Children's Hospital Little Rock identified 72% of the kids with autism have this antibody which blocks the folate. And without folate, you're not going to be able to form glutathione well. You're not going to be able to, there's a whole system that doesn't work very well, the
Hmm.
antioxidant
Hmm.
system, if you can't get folate on board.